2019 Higher Paper 2 here, and this is question number 9, focus of which is logarithms and exponentials, and using these to model in the real world. Now, this sort of question here, again, is very common to come up in an exam, and is actually a very straightforward question to work with once you get in the routine of looking at the question, deciphering the information, and learning how to apply it to the situation. Now, one thing to remember is that exponentials tend to be used to model decay or increase of something across time. That's their most common use. Now, in this one, it's looking at electricity on a spacecraft produced by a type of nuclear generator. What it says is that it can be modelled using this equation here. And in here, PT is the electrical power produced in watts after T years. Now, in this, you'll always have your dependent and your independent variable. So the power is our dependent variable because it depends on the time in the system we are at. So we have to bear in mind time. Now, time always starts at 0, and then it always goes off to however long. So in this case, it would be 0 years because that's when it's initially launched, and then it'll go on for however long it needs to be. So it's two parts to this question. Firstly, determine the electrical power initially produced, and then calculate how long it takes to reduce by 15%. Now, if we look at the first part, initially produced by the generator, just like I said a moment ago, is when it begins. So remember, initial means start or beginning. So when it begins, our t is equal to 0. Now this sort of thing here is great because with an exponential, if I put t is equal to 0 in here at the power, that's going to be number times 0, which is going to be 0, so it's going to be e to the power of 0, which means all I'm left with is that there. So what I can simply say is that P0, our initial power, is equal to 120 watts. So there you go, that's part A answered in one go. Part B then wants to know how long it takes for the electrical power produced to reduce by 15%. Now if this is the initial one, what we want to know is when PT is equal to 85% of this. So 85% of 120, because remember it's reduced by 15%, which means that we're looking for 85% of the initial power. So 85% of 120, well, that's 102 watts. So what we then know is we can set up an equation involving this to be able to calculate the time t. Now remember, we can't just guess because essentially this first equation here relates to two variables, the power and the time. We've got one equation, so we need to eliminate one of these. So we're given the power, or we have to calculate the power if you like, which gives us the value for the power of 102, which we can plug in to then find the other variable, t. So using this, I'll set up my equation. So I can set it up as 102 equals 120 e to the power of negative 0.0079 t. What I then want to do is solve this. Now to solve it, firstly what we want to do is shift everything from this side to begin with so that we're only left with e to a power. So we'll shift it so we get e to the power of negative 0.0079 t is equal to 102 over 120. Now we can leave it like that, or you can write it as 51 over 60, that's 6 and 2/3. Then we want to get rid of the e. Now in order to do that, if we take the natural logarithm ln of both sides of the equation, what's going to happen is we're going to have ln of e to the negative 0.0079 t equals ln of 51 over 60. Now this ln e, what I can do is use my rules of logarithms to bring that down to the front, and then ln of e is just 1. So what that means is I can rewrite it as negative 0.0079 t equals this ln of 51 over 60. Then it's just dividing through to get rid of the bits that we don't need and find our t. So if I divide through by the negative 0.0079, what I'll end up getting is that t is equal to our ln of 51 over 60, and that's then divided by the negative 0.0079. Now thankfully this is a calculator question. Be very impressed if you could do this one in your head without one. What I can then do is if I figure it out, what I'll end up getting is that t is equal to 20.572, continuing on from there. So based on that, you could say that the time is equal to 20.6 years. That's how long it takes for it to reduce by 15%. So there you go, we've answered the question, we've done our working through. Now this sort of question here is very, very common that comes up in an exam. This question, or a slight variation on it where you don't know the initial value and you have to work with it from there, maybe to calculate initial value or find some sort of relationship between the initial value and a value at a set time. This sort of question, like I say, is very common. In terms of marks, part A, you get a single mark just for knowing P0 is equal to 120. Part B is 4 marks, so firstly, setting up your equation. Secondly, getting to this stage here where you get the e to the negative 0.0079t equals 51/60. Third mark is for taking your ln, natural logarithms of both sides. And then your final mark is for getting the answer. This first mark here, the 102 equals 120 e to the power, you'll get that mark if you get to this step without writing it down, because it can be done as implied knowledge. So just be aware of that. If you don't write that step down, you can still get it, but I would always recommend show every single stage you're working and every single step you do, particularly in a question like this, where there can be a bit of a confusion or you're working with slightly more, let's call them funky numbers. Alright, so bear in mind all of these steps and all the points here. You should manage these kind of questions no problem.